Redmond High School Pre-Calculus presents complex numbers. Alright, some quadratic equations have no solutions. For instance, the quadratic equation x squared plus 1 equals 0. This equation has no real solution because there is no real number x that can be squared to produce negative 1. Therefore, an expanded system of numbers using the imaginary unit I was created to thus the square root of negative 1 is written as 1i. Each complex number can be written in standard form, a plus bi, a being a part of the real part of the complex number, and bi being the imaginary part, but b itself being real. If a and b are both real numbers, then a plus bi produces a complex number. If b equals 0 in a plus bi, the equation then equals a. However, if b does not equal 0, then the product of a plus bi becomes an imaginary number. When adding or subtracting complex numbers, you use the sum and difference formulas. This is done by simply adding or subtracting corresponding real and imaginary parts. Take, for example, adding a plus bi with c plus di. One would merely add a and c, and then add b and d. The same goes for subtracting. In addition, when multiplying two complex numbers, you follow the rules of FOIL. Once you have FOILed out the product, you use the fact that I squared is equal to negative 1 to simplify and collect the like terms. Complex numbers can be graphed as well. They can be visually represented as a pair of numbers forming a vector on a diagram called an R-grand diagram. This geometric representation of complex numbers is established by the real number shown along the x-axis and the imaginary part along the y-axis.